Sequential circuit testing is currently more challenging than combinational circuit testing. Design for testability was designed to minimize the complexity of testing ICs and improve enhanced fault coverage while having the minimal overhead. Designing using a single scan chain might result in a longer testing procedure. Multiple scan chains are implemented to shorten scan duration. The current solution to the problem is design for testability, which replaces the D flip-flop with the scannable flip-flop and consists of 2-to-1 multiplexer and D flip-flop. These scannable flip-flop are not optimized by the logic synthesis tool. This additional multiplexer might add an increasing amount of delay and error overhead. So I propose my idea, which is to insert scan cell using the RTL scan design technique. It has used the structure scan-aware scan description to insert scan cell and modify the RTL design to reduce error overhead by utilizing the multiplexer and operational units to insert scan cells. The multiplexer can be utilized by adding extra gates in order to control the selection signal, while the operational unit must be modified to force the side input of the operational unit to propagate to the output. Here are some of the reasons I feel my solution is preferable. Firstly, RTL scan design has the potential to decrease error overhead because we can remove the additional multiplexer by modifying the if-else statement that present the existing multiplexer. Second, this method can minimize the delay by eliminating the delay caused by the additional marks in scannable flip-flop. Last but not least, this scan insertion strategy can achieve fault coverage greater than 95%.
The RTL code need to be modified in order to insert multiple scan paths and need to verify the functionality. Once the functionality is verified, it is ready to design compiler to perform synthesis. The synthesized and optimized netlist is then placed and route are carried out by the IC compiler, which to perform floor planning, placement, clock tree synthesis, and routing. This is physical layout that obtained from the IC compiler tools. The total error from IC compiler is analyzed and compared with the conventional insertion method. The ATPG Tetramax tool then uses the netlist file to determine fault coverage. The fault coverage for RTL scan insertion is 97.26%. The synthesized netlist then undergoes static timing analysis to check the accuracy of timing paths and reduction in number of violation paths using PrimeTime tool. We can see the setup time report from PrimeTime tools where the setup slack is met.
Semiconductors like Intel, MediaTek, and Qualcomm can obtain benefit from this method to insert DFT. Because the proposed solution reduces the error overhead, there is more area to add another feature.